Hello friends. In last session, we have already learned about alpha axial haloketone rule. And this rule is application of the Quaternion effects and Quaternion effect which is help us to solve few examples based on the CD and ORD curve. And we'll try to understand the how is the distinguish of the isomers under the stereochemistry, right? So let's start with octant rule today. Okay. What is meant by octant rule? So I will share the PowerPoint presentation. This PowerPoint has made by Dr. Sharad Patil sir, and I have taken help of him. So octant rule, the sign of Quaternion effect of chiral cyclohexanone derivatives with their absolute configuration. In last session, we have already discussed about the quadrant rule, and this is the exactly related to the quadrant rule. The space around carbonyl group is divided into 8 sectors is called as octant. Why is called as octant, right? So with the help of orthogonal planes about x, y, z axis is nothing but this octant. So this rule only applies to substituted cyclohexane. Okay, hope you remember such kind of the cyclohexanone which we have already learned. Suppose we have this carbonyl, we have given the number 1, 2, 3, 4, 5, and 6. Right? So this number 1 carbon is denoted here. Then the 2, then 3, then 4, then 5, and this is 6. Right? So 2 and 6 are adjacent to this carbonyl carbon. Right? 4 is opposite to it. So based on this this octant system, so this is type of, this is 1 type, 2 type, 3 type, 4 type, like this. This is octant type of system. It has 8 sectors, and these are the 3, we can say, the axis. This is 1, this is 2, and this is 3 axis. Even we'll elaborate in the next slide how exactly it looks. The rule is applied for substituted cyclohexane is for sure. For assigning configuration based on this rule is to divide the space around the carbonyl group into 8 sectors is called as octant. These are the 4 squares. When there is a front sector, then there will be a sign in like this fashion. And when there is rear sector, then sign will be like this. So actually this front sector and rear sector is very difficult to imagine, but in next slide we'll understand. Before that, just we will read, wing will be through the carbonyl carbon, and this octant has 2 sectors, that is front and rear sectors. Okay, rear sector signs contribute to the Quaternion effect, hence they are more important. See now this rear sector is correlate with like this. Yes, exactly. So this is octant. Hope you can able to see this octant. So there are these 8 boxes, right? So this is octant. So what do you think? This side is right side is negative, here positive, here negative, here positive. So the side which we can see is this is front, and this side is rear side. Rear side, you can see here positive, here again negative, here what happened? Yes, here positive, and here again negative. Okay, so the same which they have provided us here. Okay, so this is the rear sector. See, you can imagine with this rear sector, right side positive, left side negative, positive and negative. Hope you understand now. The same is also here. Okay, we can imagine it. See here, there are three planes. So this is cycloketone or cyclohexanone. Okay, this is double bond, and these are the three planes. This is x-axis, this is z-axis, and this is y-axis, right? So one plane is with this y, another is with this x, and last one, this is parallel to the z-axis. Okay, based on that, this cyclohexane molecule is divided. So you can see two is comes this side, then 6, then 5, and the 4. Hope you understand. Even I would like to share the all PPTs present here with all of you, so you can study very well, right? Then we'll elaborate more with axial and equatorial point here. See here, actually at the fourth position, suppose this fourth position has this axial substituent and equatorial, which is, it will not that much contribute on the, or there will be not effect on the cotton effect. Contribution of the substituent in different sector towards cotton effect. Hydrogens are contribution from the hydrogens, usually we have to ignore. So there will be no effect with the hydrogen. Then substitute at the fourth position will have no effect on the cotton effect, since equatorial and axial groups are in the nodal planes. So they are in the nodal planes. So there will be not a effect on the positive or negative on cotton effect, right? So now we'll draw the axial and equatorial position on other number of carbon, which is 2 and 6. Specifically, you can see this is the, where it is, yes. So this is 2 number carbon, and this is axial. This is equatorial. Okay. Axial and equatorial. What about 6 number carbon? This is axial, and this is again equatorial. Okay. So see, so this second and 6 axial positions is contribute more on the cotton effect, right? But on equatorial position, there will be very less, again, which is parallel to the this plane. Okay, only one small, so there will be effect, but we can say this is the effect is having the very small contribution of the cotton effects. Okay, yes. So this is axial and equatorial. So we have covered this 2 and 6 position. Now we'll see towards the 3 and 5 position. 3 and 5. So the same we can write down these two position and 6 position is on different side. So when there will be substituent on second position, especially axial, so this is positive cotton, right? And on the substituent on 6th position axial, there will be negative cotton. In same way, when there will be third position, there will be a substituent, then there will be a minus cotton effect, and at the 5 position, there will be a positive cotton effect. Okay, so accordingly, try to understand this. Okay, so this is the best example. Then what about the fourth position? There will be no effect, which we already learned. Then we'll try to solve exactly one example. Yes, this example. Okay, see here. So this is the compound, namely 3-methyl-hexanone. 3-methyl-hexanone. So there are two positions. So when at 3 number position, methyl is at axial position, and 3 number position, methyl is at equatorial position. So what will happen? So when methyl is at this position, 3rd number, then there will be positive, right? And when methyl is at axial position, here is axial, right? This is axial and this is equatorial, right? So when axial position is there, then there will be a negative quaternary product, and here is positive quaternary. Okay, so this is the one example. We'll try to solve another example as well, which is 3-methyl cyclohexanone. Again, we can able to write down this. So here 3-methyl, this is axial. Okay, and 3-methyl, this is equatorial. Instead of halogen, actually they have given us the equatorial position. Okay, so what about the configuration? If instead of halogen, suppose this methyl group is there, then what configuration should be there? So the configuration here, suppose this carbon is having 1 number because of methyl, this carbon is 2, this carbon is 3. So 1, 2, 3. So this is S configuration, and the observer is at that side, right? Means this hydrogen is at back side. So we have to make it opposite. So configuration is R. Is it clear? So when R is there, means negative quaternary. Yes. So like this. Okay, try to elaborate. When you will solve more example, then you will understand. Last example we will solve and then we will stop. This is again 3-methyl cyclohexanone. The same example is there. This is trans 10-methyl decalone. Trans 10-methyl decalone. How we can write down this? Yes, decalone. Here 1, 2, 3, 4, 10. Trans 10-methyl. Here at 10 position there will be a axial. So how we can write down this? So see here in our presentation, this obviously this images has taken from the P.S. Kalsi as well as the D. Nasipuri book. The D. Nasipuri is the author of Stereochemistry. This book is also very good, and you can able to solve few examples based on this Octant rule, right? So how to write down this decalone in this format, in quadrant format, you can learn, and then you can able to answer whether this will show the positive quaternary effect, right? So I think we have tried to solve 3, 4 examples, and based on you can able to answer based on the Octant rule. Okay, and hope you understand how this Octant rule as well as quaternary effect, alpha haloaxial keto rule is very important as an exam point of view, right? So thank you and see you.